Hey everybody, it's Timbot here at the TTL Makerspace. We're here with an exciting new series for you called Freecad for Lasers. In this first episode, we're going to be learning about planning and constructing things in 3D that you'll be able to cut out with a laser like the Ortur LaserMaster 2 or even the Omni CO2 based laser that we have here in the Laser Cave. Now for this, we're going to be making use of Freecad, which is a free open source software, and it works on all platforms. So you'll be able to follow along no matter what operating system that you have on your computer. Now, the construction technique that we're going to be using in this episode is called tabs and slots. And it's a very common technique for constructing things in 3D when you're using a laser. Now, one of the problems that you can run into when you're doing this type of construction is that if your material is not a uniform thickness, you're going to run into problems with the fit when you attempt to assemble it with your slots. This one is pretty good, but it's a very common problem because even if you go to the store and you go to the exact same aisle in the exact same place and you purchase the same material twice, there's no guarantee that it's going to be exactly the same thickness. Manufacturing standards can differ. So in this episode, to solve for this, we're going to be using a technique called parametric modeling combined with aliases. This is going to allow us to assign the thickness of our material inside the software in a way that if it should happen to change, the software can recompute the entire model for us, and it's going to be a huge time saver. So let's jump into the software and we're going to set up our project.
Let's jump over into the model, and we're going to turn off the view of the sides here so we can get a little bit better look at the configuration. And we're going to be diving straight into a new document and attempting to create this arrangement here. And as we go, I'm going to pass along a few tips that I think will help make your life with Freecad a little bit easier here. So let's go ahead and set up a new document. Before I jump into anything else, the first tip that I'd like to pass along has to do with the Spreadsheet Workbench here. And I find that a lot of tutorials don't make use of the Spreadsheet Workbench, but it's actually very vital for a concept called parametric modeling. And what parametric modeling has to do with is your ability to recompute a model based on changes without having to do a ton of manual updates. If we go back to that first thing we're looking at here, we mentioned that the thickness of the material is kind of variable. It could end up being slightly thicker, slightly thinner. And so that is an area where it is very good to create what's called an alias in the spreadsheet. Let's jump into doing that, and we'll talk about what this means for us here. So let's go ahead and go to the spreadsheet right here. The first thing you'll notice is that the tools that are available up here have now changed. With each workbench that you select, you'll see that the tools reconfigure themselves with only a few exceptions. Generally, you will have these views that allow you to switch your model into different views very easily. There's not a ton of features on the Spreadsheet Workbench, and some of them won't become enabled until you actually create a spreadsheet. So let's go ahead and do that. Alrighty. So what we're going to do is start putting into the spreadsheet some of the properties that we want to create aliases from. These are the properties that could change. So the one we're talking about this time is the material thickness. I can call this anything I want, but I'm going to go with material thickness, just like this. This is going to be my my label cell. And then right beside it here, I'm going to create the actual variable and the alias. Here, let me just make this a little bigger. Here we go. So in here, I'm going to do the same thing, and I'm going to give it a value. I'm going to say, let's say 5 millimeters. All right. And you'll notice that it knows enough to format it with the decimal point. And if I right click and go to the properties, this is the crucial step that we need to do with the spreadsheet where we turn this into an alias. So go to the end tab here where we see alias, and we're going to give this basically the same name. I'm going to say material thickness. And there we go. And there's one more thing we need to do, which is to specify the display unit. Over here I'm going to say we're working in millimeters. And there we go. And that looks pretty good. Okay, so we've set things up. And now you don't have to set up all of your aliases at one time. We can actually create them as we go if it makes sense. But for now, this is looking pretty good. And we're going to jump back over into our active model here. We're going to switch out of the spreadsheet workbench, and I'm going to jump into one called the sketcher.
So let's talk about the way that CAD organizes things. If we take a look at this cool dice tray that we've got right here, CAD would consider this entire thing to be a part. Now that part would be composed of individual bodies. These can be the same or they can be different from each other. And every body would be described by sketches that provide us the outline of the part. And then that sketch would be composed of individual features that describe things like these little cutouts for the tabs and the slots that we've been working on. Now, there's also something called an assembly, which allows us to organize parts together, but we won't really be getting into that in this video. Instead, let's jump back in and do our sketching, and we're going to learn about something called constraints, a very important concept in CAD.
Click on to activate the part, and we're going to create a new sketch. And I'm going to start with the XY plane, which is basically like a top-down view of what I'm drawing here. I'll say OK. There we go. And so we automatically get this little grid line here. Now, which piece do we want to start with? Well, let's go back over to our laser lesson here. And why don't we start with this bottom piece here? So you can see it's sort of shaped like an eye, and the tabs form these little notches inside of here. So we're going to roughly draw that out in our sketch and turn that into our first body. So we'll go back into here. We're going to go into our sketch, and I'm going to select from among the drawing tools the multi-line drawing tool. Sorry, that's a B-spline, which is for curves. And then we have the polyline here, and I'm going to go ahead and select that one. And we're not going to be too crazy with our accuracy here. We're just going to go ahead and start drawing out this rough eye shape. There we go. There we are. Nothing too crazy. Just an approximate of what we need. The main point here that we're trying to do is just to create the right number of lines and points. And then we're not going to try and eyeball this thing. We're going to go in and, specify every detail here. This is very, very important in CAD modeling. So I hit the escape key to exit out of that tool. Now I'm back to the pointer. And I can begin applying constraints. Now I've got the constraints pulled over to the side here because that's the way I like to dock the windows in Freecad. And you can see that I've got 1, 2, 3, 4, 5, 6, 7, 8, 10, about 15 different constraints here. What are they used for? Well, they're used to provide information about this sketch or this feature that I'm making. And why do we need that? Well, if we take a look at the tasks tab right here, you can see that it says we've got 15 degrees of freedom. What that means is that currently the software really only knows about one thing in this sketch here, which is the center right here. It knows where the center of the world is, but every other thing here, you can see I can grab it and I can pull it around. I can do all kinds of crazy stuff here. Now that is not what we want. So we're going to start defining this out a little bit better. Now, for example, the first thing you'll notice is that this line right here is at a bit of a slant. And if I want it to be straight up and down like this, well, you see how there's a little small icon beside it here? That is the constraint. And if we look over to our tools here, we can see that that's called a vertical constraint. So if I've got that line selected and I click on a vertical constraint, you can see that it has now locked it to a certain, that it's going to be exactly vertical. That's pretty handy. You can probably guess what the next thing would be. That's right, we're going to put a horizontal constraint on this one. So if this is vertical, right beside it is the horizontal constraint. There we go. And now you can see how, we've got a certain thickness on this tab over here, but it's still unconstrained because I can move it around. And what that means is that this could be, if I'm just looking at it, this may look right, but it could be actually, a little bit off, and I just can't tell by looking at it here. So we're going to apply another constraint that will ensure that this tab is exact same thickness as this tab. And the way that we do that is using a constraint called the equality constraint. You can see to the right here, a little equals sign. That's exactly what we're after here. So I'm going to select this line. Then I'm going to select this line, and you could just click on as many lines as you want. And in fact, while I'm at it, I'm going to click on this line and this line as well, and I'm going to make them all equal. There we go. Now you can see that this one down here hasn't been made vertical yet, so let me clear that up. There we go. And so now we're getting, we're coming towards a better model here, because if I grab this one and start moving it down, you can see that all of the tabs are resizing and they're staying the same thickness. It's pretty good, right? Not bad. Now we can also imagine that we probably want this line, this line, this line, and this line to also be equal, right? So let's go ahead and do that. And now you can see like, wow, okay, we are really getting close to having a good model here, right? There's not too many things sliding around. And if we look over at the solver messages, we can see that we're down to 6 degrees of freedom. And that is not too bad at all. One of the ways that we're going to be able to get this down to less degrees of freedom is by using a very common constraint called the symmetry constraint. What symmetry does, rather than working with lines, you are working generally with points. And it allows you to say, okay, this point over here in the corner and this point on the opposite corner should always be an equal distance from the center. This is what symmetry is referred to. Let's go ahead and give it a try and see how it works. So we select one point, and the ordering matters here. We select one point, we select the other point that should be made symmetrical, then the point that they should have symmetry around, and this constraint right here is the symmetry constraint. There we go. And so you can see now that if we start pulling this around, you see how they basically stay locked, And so now we've created, positional information. And this is all looking pretty good. We're down to 4 degrees of freedom with this thing. Okay, what are some of the things that are still unconstrained? Well, if I grab this line, I can still pull these tabs out, right? They stay equal, right? But we don't know how long this line actually should be. Now, this is where it gets interesting, because these are the tabs that we're creating. And what we want to do is create a situation where that tab is basically as deep as the material thickness. Now we could, there's a simple way we can do it. We can click on this line and we can use a dimensional constraint, like this horizontal dimensional constraint that fixes the distance between 2 points. If I click it, I can say, okay, make this 5 millimeters, and you can see now I won't really be able to change the size of the tab anymore. What's happening instead is that the body here still can change size, but we're going to work on that. But the point being that this one, this one, this one, this one, because they have the equality constraint, will now all be locked to 5 millimeters. But we mentioned at the beginning that we've created this spreadsheet that defines the material thickness, right? So rather than using that hard number that, as this model continues, we don't want to have to go in and change this number everywhere in the case that, the thickness of our material changes. So instead, we're going to use a formula on this thing. Now I can change this. I can double click it and it brings me into the dialog again. Now you'll notice that there's this little formula button right here. This is what is going to allow us to access the alias we created in our spreadsheet. You might also call it a variable. I've heard it called that. Now if we click this, the way that we access the spreadsheet is simply by starting to type spreadsheet. And it gives us this little code hinting. And if we click on that, it puts a dot after it. And if we start typing the name of our alias, which I called the material thickness, we can now complete this formula. Hit the OK. And you'll see in gray here that it has computed 5 millimeters. And that's pretty perfect for what we want. There we go. Now, what's the benefit of this? Well, you see how this is highlighted in orange and it shows us the 5 millimeters? Well, this is different now because if we were to go back to our spreadsheet, and let's say we couldn't get 5 millimeter stock, so instead we went to 6 millimeter. Hit the enter, and when we go back and we refresh, see that? 6 millimeter. Yeah. Very cool, right? And what that means is that all of these tabs will now be 6 millimeter. This has a lot of implications because it means that you can start using the same models. And if you're on, say, like a diode-based laser and you're working with thinner stuff like cardstock, well, you could just go in, you could set it to like a 1 millimeter or 1.5 millimeter. If you're on a more powerful laser like we have in the space, like say the Omni, and you can go up to like 6 millimeters, maybe even more. And so simply by changing that number, you can recompute your model for the material that you're working with. That's pretty handy. I like to work with the 5 millimeter. I find it's just like easy to look at when I'm creating my model. So I'm going to switch this back to 5 millimeter. And then we're going to go back into our model here. And we're going to see if we can't get rid of some more of these remaining 3 degrees of freedom. Well, what else have we got here? Here you can probably guess. The tab width. Now that I'm working inside of here, the tab width is something else that I would really like to be able to apply an alias to. Because if we go back to our example model here, you can see this is referring to this width right here. So depending on the material that I'm working with, I might want to make these tabs a little wider or a little thinner for stability or for flexibility. So it's generally good to have an alias for both the tab thickness as well as the tab width. All right, let's go back into our model here. Let's make another alias here, and I'm going to call it tab width. There we go. How wide do we want to make it? I'm thinking like maybe a good initial value is like 15 millimeters. There we go. We're going to do the exact same. We're going to right click on it, go to properties, go to the alias, and plug in tab width. And the display unit is going to be millimeters again. There we go. So now we've got another property we can work with. Let's go back into our model and let's select this one right here. You can probably guess we're going to give it a vertical dimensional constraint. But rather than just plugging in a number, we're going to go to our formulas, look in the spreadsheet for the new tab width that we've created. There we go. Okay, so now we've got a good tab width. So our tabs, as defined by this and this line right here, are pretty well defined. And because of the equality constraint, they're defined here and here, as well as here and here, here and here. What we don't have is the overall width of this part. And we also don't have the overall height of this part, the distance between these two lines. So for these, I think we're probably pretty safe to use like a regular dimensional constraint here. So I'm going to select this point, and I'm going to give it a vertical dimensional constraint. I'm going to say about 70 millimeters. There we go. That looks pretty good. Now, if you want, you can also grab these constraints and you can pull them to the side because it can get pretty cluttered inside of your model here. And then I'm also going to give a dimensional constraint to this line using the horizontal dimensional constraint. And so this is where it gets kind of interesting, because you can use a mix of your aliases and your hard-coded dimensional information. Let me show you what I mean here. What I want to do is I want to have 70 millimeters, in this width in the center of this thing. But then I need to have my tabs on either side. Now I could say, oh, those are 5 millimeters, so I'll just add 10 to the 70, and then I'll have 80 millimeters width. And that would work, but it's not really the best way to do it if we don't want to break the parametric aspect of what we're doing here. So instead, I can click on the formula, and I can say 70 millimeters plus, and I can still go into my spreadsheet. So I'll say material thickness. There we go. And I can even multiply that. There we go. And what we end up with is 80 millimeters. But because we're using a formula, if we change our tab width, then it's also going to change the width of our part here. There we go. So that looks pretty good. Wait, what's going on here? I think I accidentally used I might have used the wrong constraint there. Sorry guys, let me get rid of that one. You can highlight any constraint and delete it. There we go. What do we got here? Yeah, it was weird. Okay, let's try that again. So we got a horizontal, and we're gonna say 70 millimeters plus spreadsheet dot material thickness times 2. 80 millimeters. There we go. That's more like what I expect to see. I think I accidentally clicked the vertical constraint there, which makes very little sense for a single line. And just like that, my friends, you'll notice that the entire model has now turned green. And joy of joys, if we look in the tasks, we find that the sketch has been fully constrained. There is nothing missing here. The software knows everything about this sketch. Now, from the sketch, we can turn the thing into a feature. And the way that we do that is by giving one more vital piece of information, which is the thickness that should be defined by this sketch. So this looks pretty good. When we're happy with this and we've got it all green, we can close it out either by clicking on the close button in the tasks here, or by clicking the up arrow on the sketch. They both do the exact same thing, and this is us signifying to the software that we're going to step back from working on the sketch, and we're probably going to turn it into an actual feature. So let's go ahead and close this out. It's automatically going to take us into this 3/4 view of the sketch that we've just created. But we're not quite ready to turn this into a feature yet, because you see, features can only exist inside of bodies. Bodies are what the software uses to create dimensional information, three-dimensional information. Right now, all we have is basically lines and points with their position, their length, and their orientation. What we need is to actually take this sketch, put it inside of a body that we can use to create a feature. So to do it, we're going to jump over into that other workbench we were talking about at the beginning, the part design workbench right here. And we're going to, first of all, create a new body. Right up here, you see this little blue block, and if you hover on it, it'll say create a new body and make it active. All right, let's go to our model here. We're going to click on our part, right? Still called unnamed one, but anyway. Now we're going to create the body. There we go. And we're going to take our sketch and drag it into that body that we just created. And in a moment, you'll see why. Let's grab that sketch. We're just going to drag it down, drop it on the body. So now it's inside of the body here. And if you take a quick look at the origin, you can see you've got an X, Y, and Z axis and plane. This is the information that is being used to position our sketch here. Okay? But because we're no longer in the sketch workbench, and now that we're in the part design workbench, you can see we've got a whole different set of tools. They look pretty interesting, don't they? The one that we're most interested in right here is called pad. And this is how we're going to actually thicken this sketch to turn it into a feature. So go ahead and click on it. And you'll notice that it gives us a default value of 10 millimeters. And you can probably guess at this point, when you see this little formula ball here, that we're going to use an alias for this. Because if we take a quick look in our spreadsheet again, we can see that material thickness is one of the things that we defined a variable for. So let's go back in here. We're going to click on the formula. We're going to go into the spreadsheet. And we're going to set the material thickness, and it is going to compute 5 millimeters, and that looks good. So we can hit the OK to finish out that task. And just like that, my friends, we have created the first part with our tabs. And if we take a quick look back into our laser lesson here, you can see it has a lot of resemblance to this bottom piece that we've created here. Now you could probably start to guess already how we're going to create these other pieces here that will form the inside of our model, which is like a little pen holder or something like that. It could be like a phone holder. The point being that once you've mastered how to create these slots and tabs, you're going to be able to construct just about anything using your laser and Freecad. So we're starting off by creating the tabs, and then we're actually going to use those tabs later on for cutting out the slots that we need. If we bring back the side here, you can see that they are nicely cut out, right? And this is going to be pretty much perfect. So back to our model here, we are in pretty good shape. So that is the end of part 1 of the lesson. When we come back, we're going to model the pieces that should sit on either side of this. And when that is done, then we're going to model the sides. We're going to see how we can precisely cut out those tabs. Now, let's jump back into, let's just do a quick preview here. If we jump back into this model here, can we actually show the benefit of the way that we're doing this? Well, let's open up the spreadsheet for this guy. And let's say we're working on the diode-based laser. And so we want to work with, say, 2 millimeter thickness. And because it's thinner, we're going to increase our tab width to, say, another 5 millimeters. And we'll make this 20. There we go. And if we go back to here, you can see how it has all become much thinner, right? But the interlocking pieces are pretty much perfect. They're wider, the material is thinner, but it all still works. This gets into really interesting territory when you consider that Freecad is an extremely versatile tool with all of its workbenches here. I'll point out a couple more of them, and you can start to picture some of the benefits that you can get, especially if you are working inside TTL Makerspace, where we've got 3D printers, CNC mills, laser cutter, full wood shop. So if I go to the workbenches that are available to us, for example, we've got a mesh design workbench. This could be used if we want to, like rather than laser cutting, if we want to 3D print any part of this model. So maybe we decide we want to do some nice thick 3D printed sides or feet to this thing. We'd be able to do it inside of the same tool. That's pretty awesome. Another one that I'll point out is the path workbench that we see right down here. This is used when you want to work with a CNC mill. And this path workbench in Freecad works very well both with the desktop Genmitsu style CNCs that we have, right up to the very powerful Omni CNC, which is like an industrial machine. You know, if you wanted to make something really fancy, like make a really nice gift, you could now be doing wood for the pieces down here, but then maybe, mill the sides out of a nice brushed aluminum, something like that. There's a variety of other cool workbenches in here as well. Like you can use the Tech Draw workbench, for example, for making very nice part drawings, if you wanted to send those off to a third party to get those worked on. And so the versatility of the Freecad tool makes it a pretty good choice, I would say. And we're off to an excellent start. Let's just remind ourselves of what we did in this lesson. And there is our first little constructible piece here. So we're going to wind it up there. And hopefully you're excited for the next part where we model the sides and then we get into cutting out the tabs.
So in this segment, we got a bit of an introduction into working with CAD. Now, there can definitely be a bit of a learning curve if you haven't worked this way before, but the advantage of it is that if you learn it well, you're going to be able to apply this skill not just to lasers, but also to other machines like a CNC mill. If we take a look at this example, it uses the exact same slots and tabs technique, but this is being done with a CNC mill instead. This is allowing me to do much thicker material, but you can tell that with the thicker material, there's even more danger of having our tabs and slots come out of alignment. And so this parametric modeling technique is going to be useful again and again for us. Stay tuned for part 2, when we're going to learn how to take the parts that we've designed in Freecad and actually cut them out on the laser here in the makerspace. It's going to be great.